Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Black Mamba by Lithium Ion. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We need to draw a 1-cell wide snake, which starts in box 5 and ends in box 9, that moves orthogonally through the center of cells. So what does it mean by moving orthogonally? It just means going horizontally and vertically. You can't go diagonally, but you have to go horizontally and vertically on the snake. The snake is not allowed to branch, intersect with itself, or touch itself, even diagonally. And cells that are orthogonally adjacent along the snake have to contain consecutive digits. So the snake is not allowed to branch, so the snake cannot do something like this. The snake is not allowed to touch itself or intersect with itself, so it cannot do something like, say, that. It cannot touch itself, even diagonally, so it cannot do something along the lines of this. This is not allowed. And cells that are orthogonally adjacent along the snake have to contain consecutive digits. So you could have something along this. So if the snake were just like this, then you could have something like 6, which would make that 5, or 7, which could make that 4, 6, or 8 here, right? So digits along the snake have to be consecutive digits. Cells that are orthogonally adjacent along the snake have to contain consecutive digits. Within each box, the box number, 1 for the top left, 2 for the top center, 3 for the top right, etc., etc. And this is typical Western reading notation. So it reads from left to right and top to bottom. So this would be the top left is 1, the top center is 2, the top right is 3, then we have 4, 5, and 6, 7, 8, and 9. But within each box, the box number 1 has to be part of the snake. So the snake has to enter in every box, then, it seems like. Because within each box, the box number has to be part of the snake. So guaranteed, the snake has to visit every box then. Cells separated by a black dot contain digits that are in a 1-to-2 ratio. And all black dots are given. So, if this were a 2 here, that means these digits would have to be 1 or 4 to be in a 1-to-2 ratio, but this digit cannot be 1 or 4 because all black dots are given. So there is a negative constraint involved in this puzzle. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so the digits next to black dots can only be 1, 2, 3, 4, 6, and 8. Because the digits, the 5, 7, and 9 cannot be. Because if they were, the problem is, 5, 7, and 9 cannot be next to a black dot, because if they were, they would be in a 1-to-2 ratio with another digit. But if you have 5, 7, or 9, you get 2.5, 3.5, 4.5. If you double 5, 7, and 9, you get 10, 14, and 18, none of which are digits. So these have to be 1, 2, 3, 4, 6, and 8. But we don't have 6 anywhere in this puzzle at all. The snake is not allowed to branch, intersect with the cell, or touch itself even diagonally. The snake does have to enter every box. And the box number has to be part of the snake. All black dots are given, though. Huh. Hmm. Um. That means. Okay, that's interesting. In box one, 1 has to be on the snake, and it must be next to a 2 guaranteed. In fact, okay, because the snake starts in box 5 and ends in box 9, it has to enter 1. The 1 has to be consecutive with 2 2s because it's not going to stop in box 1, and the 1 has to be next to 2 2s. So that means it has to be equivalent to where it is going to be in a 1 to 2 ratio with the digits that it's next to. And the only possibility then where it's going to be that case is it has to be here. So this must be 1, and it must be consecutive with 2. 1 is here, and this is also 2, and then the snake has to be on that path. So this is 2 and 1 and 2. The snake cannot touch itself, so it cannot go this way. So this is not on the path. This is not on the path. So there's no 1 or 2 here. No 1 or 2 here. This cannot be 2. So we can't have a 1 here. This can't be 2, so no 1, 2 here. This is a 3, 4, 6, 8 quadruplet here. We must get next to a 3. This must be next to a 3 to be consecutive. So this is 3 here. That means that's on the snake because it cannot go that way. We cannot have 1, 2, or 3 here. That means this is 4, 8 as a pair, which eliminates 4 and 8 in the rest of the column. So that leaves us 5, 6, 7, and 9 in the rest of the column. That means the snake cannot go this way. It has to be blocked, so it has to come this way, which is 4. So we have 4 here. This is then in a 1 to 2 ratio with 4, but it cannot be 2 because of 2 in the box, so this is 8. No 4, 3, or 8 here, so this is 6, which makes that 3 and 3 to be in a 1 to 2 ratio with 6. That means this cannot be 3 and 6. It's 4 and 8. Though 2 has to go to the 3 next to be consecutive. That means we cannot go here. We cannot go here. 4 goes here. This cannot go here. It must go 5 there. And it must enter 6. It must, or it could be 4. 6 or 4. But this is 7 or 9. That means you can't go 6 or 4. You can't be 6 or 4 here because of 6 or 4 in the box. This is 1, 7, 9, 1, 7, or 9. So it cannot reach here. The snake has to go here. it's 6. So no 6 there. We cannot go that way to get to the 8, because if we go, or this way to get to the 8, because if we go this way, we have to touch itself to get out. So the 7 has to be, it cannot be 7, 8 here. It has to be 7 and 8 here, specifically. We can't get to, or we could get 5. Right, we could go to 5. 3 has to go to 2 or 4. So it has to go to a 4, because neither of these can be 2, because they see the 2 here. This can't be 3 and 6. This is a 4-8 pair, which eliminates 4 and 8 in the rest of the row. So it's 5, 6, 7, 9 here. Therefore, we cannot go here. This has to go this way to get to 4. Could go 7 here, but then that would force 8 to be here, or 8 to be here, but then it can't get to 9 without touching itself. So you cannot go this path. We have to go this way. But it could be 5 or 7 here. You can't reach 4 or 8 here because of the 4-8 pair in the box, so we have to get 4. You can't get 6 here because of 6 in the box. So this has to go this way. And this is 4 or 8 there. No 6s here, which means this can't be 3 to be in a 1 to 2 ratio with those digits. This can't be 1 because there would have to be a black dot between them, and all black dots are given, so no 1 here. This must be 1 there. We could go 5 here. We could go 5 there. Not sure. 6 is definitely one of these 2 digits here. So if we go 5 here, I guess we could go 4, right? That is possible. Remaining digits of row, box 1. No 5, 6 here, no 5, 6 here. No 6 or 8 here. We have a 7, 8, 9 triplet here. This can't be 8 because there's no black dot between them. So this must be 8 here, which means 8 cannot be any of these digits here. This can't be 4. This is a 4-8 pair, so this can't be 4 or 8. Remaining digits of row 4 are 1, 5, 7, 9. This is not on the snake because it would be touching itself there. If we go this path, it has to be 5, and then we'd have to have 6 there. So that's possible. If we go this way, it cannot be 3. It would have to be 5 this way. 5 would have to be consecutive with 4, 6. Can't be 4 here, but if this is 5, that would force this to be a 6, 7, 9 triplet, which means 6 could not be here. So then that would not work. It would have to go this way. So either way, it has to go here. And it's 4, 5, and this is 4 or 6 here. Or 4, 5, and 4 or 6 there. We don't know. So it goes here, here, it would have to go here. If it goes here, here, it would have to go here. So either way, then this has to be 3, 5, or 7. If this is 7, the problem is this would guarantee that 6, and this 7 and 6 would eliminate 2 of the 4 possibilities here. So these 3 cells would have to only have 2 possibilities, which is not allowed. So this cannot be 7 here. It's 3 or 5. Four is in box 4. 1 is in box 1. We cannot go here. We can't go back in here because we need to exit back out that way. So this has to be 7. That leaves this as not 6. This has to be 8. Because we need every box, in every box, the box number is on the snake. So that we have 1, 4, and we have 7 there. We need 2 somewhere here. 8 eliminates 8 from being here. Eight can get to 9 or it can get to 7. We don't know which. 1 eliminates 1 here. This is 4, 8 as a pair. This can't be 3, so this can't be 6 here. These are not part of the snake because you have to end in box 9 and box 5. We have to have 5 be on the snake in box 5. If we go this way, it's 5. If we go this way, it's 5. So that means this can never be 5. It's 3. That means this can't be 3 and 6 as a pair. It's 1 and 2 as a pair here. So this is a 1-2 pair here to be in a 1-2 ratio. This can't be 2 then, which means that's fine. So this can't be 6 at all. It must be 4. Since this is 4, this can't be 4 here. We need to reach a 2. So the 2 in box 2 has to be one of these 2. We don't know which. Either way, the 2 has to get to a 1. And there is no black dot here. So this can't be 2 and then 1 here. So this must be going this way as 2. Then we have 1. Then we have 2. And that's the black dot. One of these is 5. We don't know which. We have to reach 3. 3 can't be here. We can't touch ourselves this way. So these are not on the path. So this can't be on the path. Can't touch ourselves. So it must go 3 here. So this is 3. We need to reach 4. So this must be 4 here. That makes this 8 here. This cannot contain 3 or 4, so it cannot be 4 and 8 as a pair, or 3 or 4, or 2 or 4. So this must be 2 and 1 here. We have to go 3, 4 here. We have to go to 5, but we can't go here. We can't. This is all not on the path. So we must go on the path here. So then that's 5. That means no 5 here, no 5 here. We have to get to 6. Well, we could go 4, technically. So we could go that way. We can't go here. 8 eliminates 8 here. This can't be 1 and 2 in a 1-2 ratio. 2 eliminates 2 here. So this is 4, 8, or 3, 6 as a pair. One of these is 5. We're not sure which. Remaining digits of box 3 are 5, 6, 7, 9. Remaining digits here are 1, 5, 6, 7, 9 with 8. So no 8 here because of 8 in the column. Hmm. If we try going this route, it would be 5, 4, and then we'd have to get to 3, which would be there then, but we can't have a 3 there because of 3 in a row. So this cannot go this route, which means it must go this route, which is a 6. We have to get to 7 then, and then 8. So one of these is going to be 7. We don't know which. We cannot go this path. If we try going this route, that would be 7, then 8, but that can't be 8 because of 8 in the box, so we have to go 7 this way. That's 7. We could go 8 there. So these are not on the path, or on the snake. 7 eliminates 7 there. We could go 8 here. We can't go 8 here, so we have to go 8 here then. So this is 8 on the path, which means this is 4. So 8 eliminates 8 here, so it's 4 and 8. And we have to get to either 7 or 9. We can't get to 7 here, here, or here, so we must get to 9 here. And that's all we need. We cannot enter anywhere else, actually, so this is the end of the snake here. We cannot touch it. So these are not valid to be on the snake. We can't touch it here. We can't go here and then exit back in to get to box 5. So none of these are on the snake. You can't double here and then double back because it would be considered touching itself. So we can't go there. 8 can't get to 7 or 9 here. So that 8 has to go to here. And it cannot be touching itself. Well, it can't be reaching any of these. No 7 or 9 here. It's 5 or 6. That means this is guaranteed to have a 7 or 9 here, which means it cannot be 7 or 9 there. 5 and 6 eliminate 5 and 6 here. This has to go to 7 or 9 here, which means the remaining digits in the row, this can't be 6, whereas 6, it has to be there. And we have to get to the 5. Well, we can't go there because that would be considered touching itself. We start in box 5. And we have to have 5 as part of the set. We cannot go, we can't go 9 and then 8. So this has to be 7. This must be 6 going there. So that's 7 eliminates 7 here. So that's 9 and 7. No more 9 here. No more 9 here. 7 eliminates 7 here. So that's 9. So we go 7, 6, and then this must be 5 as the snake. The rest of these cannot be part of the snake. 7 eliminates 7 here. It's 1 or 9. We have 1, 2, and 9 remaining here. 2 cannot be next to the 4 because then that would be a 1 to 2 ratio without a block dot there. So 2 has to be there. 5 eliminates 5 in the rest of the column. 6 eliminates 6 in the rest of the column. 8 eliminates 8 in the rest of the column. No 7 here either. Remaining digit of row 6 is a 3. Those cannot be 3 and 6. It's a 2-4 pair. 2 cannot be here because there would need to be a black dot between them because 1 and 2 are in a 1 to 2 ratio. So it's 4 and 2 there. 7 eliminates 7 here, so it's 5. There's no more 5 here. It's 6, 7 as a pair. That 6, 7 as a pair eliminates 7 here, and 9 eliminates 9 here. So this is guaranteed to be a 5, but we don't know if it still could go this path. Very unlikely, but still possible. Remaining digits of column 2 are 1 and 3. Remaining digits of column 3 are 2 and 9. Okay, remaining digits of row 7 are 2 and 3. This can't be 2 because of 2 in the column, so that's 3, which makes that 2. 2 eliminates 2 here, so it's 9 and 2. This can't be 1 because that's a 1 to 2 ratio with 2, and there's no black dot there, so that's 3, that's 1. Remaining digits of column 7. We have 3, 5, or 6. No 3 here because of 3 in the row, so 3 has to be here. Remaining digits of column 8 are 7, 8, and 9. No 9 here because of 9 in the box, so this is 7, 8 as a pair, which eliminates 7, 8 in the rest of the column, so no 7 here, that's 9. No 5 or 9 here. No 9 here. This has to be a 1, 9 pair here. 7, 8 pair in box 9 means this has to be 5 or 6. Okay. Where is 8 in row 2? It can only be here. Remaining digits of column 4. We have 1, 5, 6, and 9. No 1 or 9 here because of 1 and 9 in the row. Column 5. We have 1, 4, 7, 9 here. No 1, 9 here as a pair. 4 is in a 1 to 2 ratio with 2, so this can't be 4, so this is 7, which makes this 8 and 7. 8 eliminates 8 here, so it's 4 and 8. This can't be 5 or 6. This cannot be 7. This is 1, 4, 9 as a triplet. This can't be 4 because of 4 in the column, so this is 1, 9 here. This is 5, 6 here. 1, 9 as a pair eliminates 1 and 9 in the rest of the row, so this can't be 1 or 9. It's 4. 7 eliminates 7 here, so it's 9 and 1, which means this can't be 1, that's 9. 1 eliminates 1 here, so it's 9 and 1. 9 eliminates 9 here, so this becomes a 1, 5, 6 triplet, which eliminates 1, 5, and 6 in the rest of the box. So no 5 or 6 here, it's 7. 9 eliminates 9 here, so it's 1 and 9. That means this can't be 1. Where is the 1 in box 2? It has to be here. So that's 1, so this is not on the snake, this is on the snake. And 3 cannot be next to 6, because that would be a 1 to 2 ratio. These both cannot be 6 because they're next to 3. So these has to be 5, which makes this 6, which makes that 5, which makes that 6. 5 eliminates 5 here, so it's 6, which eliminates 6 here, so it's 7, which makes this 5, which makes that 6. And 6 eliminates 6 here, so it's 7 and 6. And that's the solution. Yeah, fairly straightforward. I guess the break-in was interesting because you had to figure out where 1 had to be, right? And then everything else sort of flowed from that. And then you had the negative constraint, which definitely forced you down a certain path, I should say. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.